Okay, let's talk about a huge leap forward in AI text generation. There's a new model out from Tencent that's not just a small step up, it's a fundamental change in how fast AI can write. So the model is called WeDLM, and get this, it's generating text up to 10 times faster than the super optimized models we're all used to. And this isn't some theoretical number from a lab. This is a real-world performance boost that could seriously change how we use AI every day.
So yeah, that's the million-dollar question, right? How in the world did they pull this off? Well, to really get it, we first have to understand that there are basically two different ways an AI can go about writing text.
It really boils down to two different schools of thought. You've got the classic traditional method that's been around for a while, and then you have this newer, more radical approach, the one that WeDLM seems to have finally cracked.
This slide lays it out perfectly. On one side, you have your traditional models, like GPT. They think like us, writing one word after the next in a straight line. But on the other side, you have diffusion models. They look at a sentence, see a bunch of missing words, and try to fill in all the blanks at the same time.
And that was the big promise, you know? It just makes sense. If you can guess 10 words in the same time it takes another model to guess one, you should be way, way faster. It's such a simple and powerful idea, but for the longest time, it just didn't work out that way in the real world.
And this is where the story gets really interesting, because even with that brilliant theory, these diffusion models were actually pretty slow. There was some kind of hidden problem, a bottleneck, that was completely killing their potential.
This was the question that was driving developers crazy. You had earlier models, like one called Lada, that showed this exact issue. Sure, they could predict words in parallel, but if you put them in a race against a GPT-style model, they'd often lose. Something was seriously wrong under the hood.
Well, the culprit turned out to be this thing called the KV cache. Now, the best way to think about the KV cache is as the AI's short-term memory. When a regular model writes, say, the quick brown fox, it remembers all the work it did for the quick brown, so it doesn't have to start from scratch when it adds fox. It's an absolutely critical trick for speeding things up.
And here's the problem in a nutshell. Traditional models only look backwards, left to right, which works perfectly with that short-term memory, the KV cache. But those early diffusion models, they needed to look in all directions at once, forwards and backwards, to fill in those blanks. And that approach completely broke the KV cache. It forced the model to recalculate everything from scratch for every single step. It was just shockingly inefficient.
And this is where the entire field was, just stuck. They had this amazing idea that was super fast in theory, but it was basically useless in practice because it couldn't work with one of the most important speed-up tricks we have. It was a total dead end.
But this is where the team at Tencent comes in. They didn't just have one solution. They had a brilliant two-part fix that completely gets around this problem. They figured out how to get the best of both worlds.
Okay, the first solution is called topological reordering. I know, it sounds super complicated, but the idea behind it is actually genius in its simplicity. Basically, they asked, what if we could trick the model into thinking it's working from left to right, even when it's not? That way, it could use that crucial KV cache.
So here's how they do it. Imagine you have a sentence with some words missing. The model takes all the words it already knows and literally shuffles them to the front of the line, leaving the blank spots at the end. This clever little trick lets the model process everything in a simple left-to-right order, which means the KV cache works perfectly. It's an absolutely ingenious workaround.
But they didn't stop there. Fixing the KV cache was only half the battle. They also had to make the whole process way more efficient. And that brings us to their second innovation, the dynamic sliding window. Just think of it like a non-stop conveyor belt for words.
See, the old way was to work on a batch of words, then stop, wait, and start on the next batch. That created a lot of wasted idle time. But WeDLM's conveyor belt approach is continuous. The second a word is finalized, it's sent out the door, and a new blank spot is pulled right in. This keeps the GPU busy 100% of the time, maximizing its output.
So when you put these two ideas together, that's where the magic really happens. Topological reordering solves that fundamental problem with the KV cache. Then the dynamic sliding window makes the whole process hyper-efficient by getting rid of all of the downtime. Together, they finally unlock the incredible speed that diffusion models were always supposed to have.
So what does all this technical stuff actually mean for us? Well, this isn't just an academic exercise. This has huge, real-world consequences for the future of AI.
What it means is we now have a proven real-world performance boost of 3 to 10 times. This is the proof that diffusion-based language models are no longer just a cool theory. They're a practical and in many ways superior alternative that can actually outperform our best systems today. This completely changes the game.
All right, so let's do a quick recap. We learned that diffusion models had this hidden speed problem because they couldn't use the all-important KV cache. WeDLM solved this with two amazing tricks. First, shuffling the words around with topological reordering, and second, creating a non-stop assembly line with the dynamic sliding window. The result? A massive leap forward in how fast and efficient AI can be.
And that really brings us to the final, most exciting thought. For so long, the big limits in AI have been speed and cost. Now that a huge barrier to speed seems to be coming down, what does that make possible? Could we see AI assistants that respond instantly with no lag at all? Or AI that solves complex problems in seconds instead of minutes? The door is just starting to open.